Hey guys, we're going to do a little math review for physics since it's probably the beginning of the school year and you've forgotten some of the basic math that you need for doing physics. In particular, this video is going to cover the subject of trigonometry. Now, if you remember nothing else from trigonometry, I hope you at least remember the acronym SOHCAHTOA, but maybe perhaps you have forgotten what this stands for. So let's talk about that. All of the triangles that you're going to deal with in well, at least with the basic trigonometric functions, are going to be right triangles. So, excuse me, I didn't draw in the 90-degree. There we go. All right, so that is a right triangle. When we talk about the SO part of SOHCAHTOA, that relates to the sine function, which is related to O and H. Well, what the heck are O and H? What do those stand for? And I'm sure most of you remember that the O and the H stand for opposite and hypotenuse. All right, now sometimes people aren't quite sure, looking at a triangle, which side is opposite. Usually we can pick out the hypotenuse, right? That's going to be the R here, okay, the way I've drawn it. I'm calling the sides X, Y, and R for my own reasons. But sometimes people sort of fumble on which side is the opposite. And I think the reason they fumble on that is it depends on which angle you happen to be looking at. Now, the angle that I have marked as theta is the one that we're really looking at. And so the side which is opposite to that angle is y over there. Y'all see y is opposite to that angle. Okay, so that means that side y, whatever its value is the opposite side. And of course the hypotenuse is r. How we would use this depends on what exactly we're looking for. So if we know r and we know the angle theta, I could plug in sine theta into my calculator, and then I could use algebra to solve for whichever of these other two I didn't happen to know. All right, so if I knew theta and I knew, let's say, r, right, I could plug in those numbers and multiply r times sine theta, and then I would know what y was equal to. You also may sometimes have to use inverse trig functions. So if you know what y and r happen to be, you can plug those two values in, divide, and then on your calculator, if you're using a TI-83 or 84, you would type in inverse sine. That's sine -1, like to the -1 is what the key looks like. And then it would be of whatever y over r is, and then it would spit out the value for the angle theta. Okay, now, we'll look at more at algebra later. Let's keep going and look at some of the other trig functions. The cosine, adjacent over hypotenuse. Once again, people kind of forget which side is adjacent. Well, that's easy. That's the side that's touching the angle theta that you happen to be talking about. So in this case, adjacent over hypotenuse would be related to not y and r, but x and r, because x is the adjacent side and r is still the hypotenuse. And then, of course, there's my personal favorite, which is the tangent function. It will become more and more obvious why tangent is the most useful function in physics as we get deeper into the course. But tangent, being O over A, the TOA, right, is opposite over adjacent. Which means then that, assuming that we are using this angle theta here, opposite over adjacent would be y, the opposite side, over x, the adjacent side. Now, supposing, just for the sake of argument, that we weren't using this angle down here, but instead the angle that they gave you, that everything's going to be related to, is this theta right here, right? The other corner of the triangle that's, not the right angle. Well, in that case, all of your references to opposite and adjacent switch. The hypotenuse is still the hypotenuse, but the sine function is no longer related to y and r. It would be related to x and r, because if theta is up here, then the opposite side to it would be the x, and the adjacent side would be the y. So depending on the angle that is given to you, exactly what x and y, adjacent and hypotenuse, happen to be may change for a particular triangle. So pay attention to which angle they are actually telling you whenever you do any kind of a problem. All right, and then draw the right triangle. And I mean, if it helps, you know, draw in, all right, here's opposite, right? Opposite side for this angle is the x. You can see that's what I'm using here and here. And the adjacent side is the y. And you can see that's what I'm using here and there. All right, let's look at a particular example to help you sort of apply it to, I don't know, a real problem. I mean, a very real problem, like someone is taking their drone for a walk. Okay, but fine. For us, what we want to know is, in this case, what is the height above the ground? The guy's got a 10-foot leash that his drone is on, and it so happens that his arm and the leash are at a 37-degree angle. Looks like I'm neglecting the length of his arm. Whoops. Well, oh, hey, how about that? I don't care because this distance is labeled as 5 feet. So all that we really need to worry about then is for this triangle right here, what is the height of that triangle? Given that we know the angle and the 10-foot distance there being the length of the leash, we should be able to figure out how high this part of the triangle is, as long as we pick the correct trig function. So to help make our work a little clear, I've redrawn the appropriate reference triangle down here. Hypotenuse is 10, angle's 37 degrees, and the question mark side is the one that we want to know. So pause the video at this point, take a moment and figure out, am I using sine, cosine, tangent, right? Which sides am I being given? Which sides am I being asked about? Which angle am I being given, right? So take a moment and figure out, is it going to be sine, cosine, or tangent? And then resume the video when you think you've got it. So based on what I'm seeing here, the opposite side would be the one labeled with the question mark. And we don't really care what the adjacent side is. At least they're not asking about it. And the 10-foot leash is the hypotenuse. So given that we know the hypotenuse and we want the opposite side, it looks like the sine function is the most appropriate thing to use. Plugging into it, we should get this result. And then go ahead and do the algebra and the calculator work. Oh, and very importantly, I don't know how many of you are familiar with radians versus degrees. Sometimes your math class will use radians. In fact, I would say all the time, if you're in calculus, it's going to use radians instead of degrees. So check your mode, meaning hit the mode button and make sure that it says degrees, not radians. Physics class will always use, at least for any geometry type question like this, will always use degrees. Okay, and then go ahead and calculate the answer. And we should get about 6 feet. I'm doing a very, very slight amount of rounding. Maybe it's like 5.98 or something. But basically, this dimension right here is 6 feet. And so therefore, the drone is a total of 11 feet above the ground. All right, let's maybe look at one other question, just because it's going to involve some basic geometry formulas in addition. All right, so here we have an intrepid physics student who is determined to explore the dimensions of this strange conical object about whose origin he seems strangely uncurious. So he's got in one hand a meter stick and in the other a tape measure. And let's say that he determines using the tape measure that the circumference of this cone happens to be, I don't know, let's make up a number. How about 5 meters? Sounds good to me. And using the meter stick, he can determine that the sort of edge of this cone is 2.5 meters, let's say. Or maybe pick an easier number. How about 2 meters? There we go. All right, so it's 5 meters around, 2 meters along that side right there. And let's suppose that the question being asked is, how tall is this thing, right? What is the height? Where, of course, the height would be this dimension. Okay, now, if you think you know how to approach this, then go ahead and pause the video and resume it whenever you think you've basically got an answer, and then you just want to watch me confirming everything that you just said. if you're not quite sure how to proceed, then you can not pause it and watch, and pause whenever you feel like you can get a step ahead of me, okay? And then resume and let it catch up. So probably the first thing that we should do is figure out sort of what do we know, what inferred triangles do we have here that can maybe help us figure stuff out. And there's sort of a secret right triangle buried in here, and that would be this one right here. We don't know this angle down here. That's not really given to us. But the side that we do know would be the hypotenuse. Okay, so that's that 2 meters. So we've got a 2 meter hypotenuse, and the height would be the vertical leg. And so there's some way that we should be able to figure out maybe what this other leg is so that we can get the height. Okay, now what would that method be? Well, nothing with trigonometry, actually. This is where we're going to have to go back to simple geometry, right? This is the radius of the circular base. And the circumference was 5 meters. All right, now, formula for the circumference of a circle. If you don't recall, it would be 2 pi r, or some people prefer to say pi d. I'll go with 2 pi r. Sounds right to me. Where r would be that right there, and that happens to be the bottom leg of the triangle. Okay, so now all we got to do is divide 5 by 2 pi, and that will be what the radius is. And my fancy calculator says the answer is basically 0.8 meters. Okay, all right. So now I know the hypotenuse, and I know that one of the legs is 0.8 meters. Now, getting the height of that triangle, which is the height of the cone, doesn't actually involve trigonometry. It's going to involve some other property of triangles that you should be very familiar with. Let's see, that would be the Pythagorean theorem. That's right. The Pythagorean theorem says a squared plus b squared equals c squared. So not all triangle problems are going to be trigonometry problems, right? Some of them are going to involve, a lot of them are going to involve the Pythagorean theorem. So A and B are the legs, C is the hypotenuse. Okay, so that means that we know one of the legs, so 0.8 squared plus b squared, that'd be the height. And then C, that's the hypotenuse, so 2 squared. All right, so after a little bit more calculator work, we can determine that the height of the triangle is 1.83 meters. Okay, well, that's the height. Wonderful. 1.83 meters. Now, other questions they could ask here might be, what is the angle, right? What is this angle theta down here? If we want to know that, we could actually use any of our various inverse trig functions. So I won't tell you which one to use or how to set it up. I'll just tell you, here's the answer, and then you see if you can make your calculator cooperate and give you that angle theta, which should be 66.4 degrees approximately. All right, so if you can make your calculator cooperate and give you that angle, go for it. And you have mastered what you need to know about trigonometry. All right, well, I hope that was helpful, and good luck on the homework.